Hello guys, welcome back to Prime Tracks. In this tutorial, we'll be designing a continuous beam as per Eurocode 2 and we'll be using Python programming language. This is also going to be an interesting one, so stay tuned to the end. As seen on the screen, we have a continuous slab with three panels, that is panel A, B, and C, and bounded by peripheral beams with dimensions 250 by 450, as well as internal beams with same dimensions, that is 250 by 450 mm. Again, the slab thickness is 150 mm and the dead load of the slab is 7.1 kilonewton per square meter. The live load is 2.5 kilonewton per square meter. The cover to reinforcement we'll be using is 25 mm, and the beam dimensions, as I mentioned earlier on, is 250 by 450 mm. So the first step in designing the beam is to determine the load distribution. So we'll look at how to determine the load distribution from the slab onto the beam, and then eventually we'll look at how to calculate the ultimate loads. I have a comprehensive tutorial on this, and I'll leave a link to the tutorial in the description below. Right, so to start off, we'll determine the load distribution acting on the beam. So determine load distribution, and under this we'll have another subheading, so aspect ratio. And the aspect ratio is basically the ratio of the long span to the short span, and we will denote that by K. So our K is giving us Ly on Lx, where our Ly is the long span and the Lx is the short span. So if K is less than 2, then we say the slab is two-way. If K is greater than 2, then the slab is one-way. And then we'll have to establish another condition. That is when the slab has equal dimensions. So if K is 1, then we would say triangular load distribution. And later on, we'll look at how to draw the load distribution within the panels. So let's continue. So we are going to consider panel A. So the aspect ratio for panel A, K, as mentioned earlier, is Ly on Lx. And our Ly for panel A is 5,800 and the short span is 4,500. If we work this out, we'll have 1.29. Again, for panel B, our K will be equal to Ly on Lx, which is 5,800 on 5,000. And that will give us 1.16. Similarly, for panel C, our K is Ly on Lx, which is 6,500, and the short span is 5,800. This will give us 1.20. So for panel A, the aspect ratio is less than 2, same as panel B, the aspect ratio is 2, and panel C as well, the aspect ratio is less than 2. So we can say the three panels are all two-way slabs. So we can say panel A, B, and C are two-way slabs. So our second step, so that will be B, we are going to draw the tributary loads on the beams. Okay, so this is the tributary areas on the beams. Mostly the trapezoidal loading always goes to the long span, and the triangular loading goes to the short span. So that is the principle we use in drawing the tributary areas on the beams. Now let's determine the loadings on the beams. So we start off with beam A, that is for panel A. So panel A, and we are considering beam. So the loading on beam A would constitute the tributary load from the slab, And again, we'll consider the self-weight of the beam. So the ultimate load on beam A, so that is made up of the tributary load from slab and then the self-weight of the beam. Right, so we'll be using a formula to determine the ultimate load. Now, since beam A has a triangular load distribution, the formula for the ultimate load is given as, so UL, we are denoting ultimate load by UL, would be given as 1.35. So that is the partial factor of safety for dead load multiplied by NDL multiplied by LX on 3. So this is the dead load from the slab, and then we'll consider the self-weight of the beam. So self-weight of beam, let's denote the self-weight of beam by this, and then we'll consider the life load part. So that is 1.5 multiplied by NLL multiplied by LX all on 3. So this part of the formula is the dead load, and then this part is the life load. So this is the dead load from slab, and this is the life load. So this is the dead load component, and that is the life load. Okay, where NDL is the dead load of slab, NLL is the life load of slab, LX we know already is the short span, and SW beam is the self weight of beam. Now slotting the values in the equation, we'll have our ultimate load being equal to 1.35 multiplied by NDL, which is 7.1, that is the dead load of the slab, multiplied by the short span, which is 4,500 for panel A. Converting that to meters, we'll have 4.5, all divided by 3, plus the self-weight of the beam, and that is the cross-sectional area of the beam multiplied by the density of concrete. So that is 0.25 multiplied by 0.45 times the density of concrete, which is 24, plus 1.5 multiplied by the life load multiplied by the short span, which is 4.5, all on 3. So if we work this out, we'll have the ultimate load on beam A will be equal to 22.7 kilonewton per meter. So we'll move on to panel B. So panel B, and then again we are considering beam. So we are considering beam B, this beam. And again, it has a triangular load distribution. So we'll use the same formula we used here. So our ultimate load, which is UL, will be given as 1.35 multiplied by NDL multiplied by LX all on 3, plus the self-weight of the beam, plus 1.5 multiplied by NLL multiplied by LX all on 3. Again, we slot in the values. We'll have 1.35 multiplied by NDL, which is 7.1. For panel B, the short span is 5,000 and the long span is 5,000. So multiply by 5 plus the self-weight of the beam, which is 0.25, multiplied by 0.45 times the density of concrete, 24, plus 1.5 times the life load, which is 2.5, multiplied by the short span, which is 5, all on 3. And that will give us 24.9 kilonewton per meter. So that is the ultimate load acting on beam B. Now let us consider panel C. So panel C, in this case considering beam C. So we are now considering beam C. And then the loadings on beam A, beam B, and beam C will be similar to the loadings on this beam because we have the same dimension. So our ultimate load, now considering panel beam C, it has a trapezoidal load distribution. So we are not going to use the formula we used for panel A and B. In other words, we are not going to use the same formula we use for beam A and then B. We are going to use a different formula, and we've seen this formula before in my previous tutorial on beam load calculation. So in this case, our ultimate load our UL will be 1.35, still remains the same. That's the partial factor of safety for dead load, multiplied by 1 on 2, multiplied by NDL, multiplied by the short span, all into bracket 1 minus 1 on 3k squared, plus the self weight of beam. Then now we move on to the life load component, so plus 1.5, that is the partial factor of safety for life load, multiplied by 1 on 2, multiplied by NLL, which is the life load of the slab, multiplied by Lx into bracket 1 minus 1 on 3k squared. So again, slotting in the values,